Hello everyone, welcome. My name is Nas-AI-TV. I'll be walking you through on how to get started on submitting on CrunchDAO, majorly the new dataset, which is master dataset. So firstly, I will try to let us know what CrunchDAO is. CrunchDAO is a data science competition platform for data scientists to learn, improving their modeling skills and earn on weekend basis. They run a series of datasets made of financial dataset. In a nutshell, CrunchDAO is a research team leveraging the power of collective intelligence and Web3 to produce next-generation financial predictions. If you want to get to know more about CrunchDAO machine learning competition, you can try to read my blog post here. I'm going to be reading this code on my GitHub repository, which I'm going to share on my YouTube channel. So the outline of this notebook is for us to load the data, investigate the data validation and correlation analysis, the validation scheme used, the machine learning model used, and submit our prediction on the CrunchDAO platform. So let's load our data. Yeah, you can see I'm trying to load my data set using Google Colab. So one of the importance of using Google Colab is that you don't have to worry about maybe your computer does not have a lot of memory space. You don't have to worry about downloading data set every week continuously in order for you to get started with CrunchDAO. CrunchDAO already have an API whereby you can try to load data set every week, trying to use this particular HTTPS in order for you to do your train data, your train targets, and your test data. So you can also see the execution minute of how the data set is being running here, so which is more faster here. So now we want to investigate our data set. What do we call by investigating data? We want to know the shape of our data. We want to check if there's missing values. We want to check if there's duplicate values. So the shape of our data mainly consists of what? 300,000, and then we have 618 columns, and we also have our train target, which we see that is it only has 6 columns, and our test data is less than 15,000. So let's try to look at how our training data. So we see that we have a lot of high dimension columns, which is 618 columns in our data set. So checking the missing value of our data, we observe that we have no missing values in our data sets, and then there is no missing values and duplicate values in our data. Now majorly to want to check about our target prediction. If you want to get started in CrunchDAO, I'm going to show us a way to get started trying to read the blog post, and you can also read the documentation. On the new master dataset, we have 4 main targets to predict at the same time. We have the target W, target H, target G, and target B. So mainly this is best known to the CrunchDAO, but when you try to look at their documentation, you get to know more about. So here now we want to check distribution of our targets. So we observe that the target D and B have similar distribution, but most importantly, the 4 target they are ranged from 0 to 1. So the next step for us is to match our data set. We want to match our train data and the target columns in order for us to have some analysis without trying to have a lot of problem with that. So we made that to have a new shape in our data. So finding the unique data that are joined together to master a data. So we want to find the unique column names. For each column, we want to find the unique name for them. So mainly we have 10 unique column names, and looking at them, we observe that the likes of the moons, Kinetic, Gordon, Wirth, V-ratios, 3B signal, Dolly, and C mechanics all combine making data sets. So we want to do a data visualization on our data. So we want to visualize some of the features that combines to make a data set, a master data set. So we have the 3 big one signal. We observe that the feature one for each of the ones, the comprise of the data that makes a master data looks similar in distribution. So but if we check across each feature, we can see difference. So the general observation is that distribution looks the same across all data combined. All data points have been standardized. So if you want to know more about why the features for each of them looks from 0 to 1, you can try to click on this particular documentation and try to see how the feature engineering for this data set is being done by CrunchDAO. So we want to look at the moons. Looking at the moon is something very important. We want to see if there is a particular moon that has maybe moon 1 has 300 values and moon 20 has 10 values. We observe that across all the moons there is no much difference, because the one with the highest count has 0.029 and the lowest has 0.025, so there's no more difference. And we also check that the unique values of our moons is 358, and looking at the test set too, they follow the same distribution. So let's try to find the number of unique for each month. So for the trained data, our unique month is 358. So original data have been collected 358 times. Let me try to simplify like that. And for our test set, we have 13 months. The gen data I've collected what 13 different times. So we observe that there is no more difference by frequency count of each month. So now we want to look at the top 15 correlation with each target. Remember I said we have target W, R, G, and B. So looking at the correlation for each of them, for target W correlation, the highest of 15, we observe that our data, most of the features are from A kinetics and C mechanics. And for target R2, they are from C mechanics and what? They are from C mechanics. And then for target G, we have most of them we have read name, and for target B, most of them are for what? Read features too. So we should take note of that. So for target W and target R, features contain mostly kinetic and C mechanics data, and for target D and B, top 15 features mostly consist of read data. So now the next thing for us is to curate our submission format. So the submission format means that we have to have 6 columns that is going to be accepted in order for you to make, after making your prediction, to see how your score will perform on the live score leaderboard next week on your Crunch data. So now, the next thing for us is to set our cross validation scheme. Cross validation scheme in this notebook, we use one old cross validation without taking randomness into consideration because the months have time series distribution nature. So the data set are collected in time, so we should be careful of not taking randomness into consideration because randomness might not make us to make accurate prediction and might also cause what we call data leak, whereby you are trying to leak something the future into the past or past into the future. So we should take note of that. So in order for us to have our train and validation data, so the train data consists of for the months from 1 to 340, and the validation data is from what? The months from 341 to what? To 358. So why are we doing this? Training data is for you to train your data on, and validation data is for you to validate what your model, how is your model is performing across target on. So we want to see the shapes we have. The shape for our training data, which for the S train is 293,000, and we can see what the columns is, and our row for the validation is 14,000. And remember, our test set is something around 10,000 rows. So we should also take note of that. So the validation score, the performance of the model is tested with Spearman correlation. Spearman correlation rate from 0 to 1. The closer to 1, the better the model. So the model performance will be represented by percentage here. So we try to define a function in order for us to use our Spearman correlation. The next step for us is for us to choose a suitable machine learning model in order for us to make accurate prediction on. So now I'm going to be choosing the light GBM model. So why light GBM? One of the benefits is faster training speed and high efficiency and better accuracy. And if you have been doing computer data for a very long of time, you check a lot of people trying to do winning solution on Kaggle Zindi, you see mostly a lot of them use light GBM models because it is super fast, and there have been a lot of resources and research papers on how to optimize your light GBM model, which are also quite to be useful for this particular master datasets. That's just the reality for this. So now I'll be setting my model, and the only parameters I'm trying to use the number of leaves. So we have a lot of columns, so I'm turning 256 in order for me to make sure it's going to learn faster and for us to get started with our light GBM model. There are better ways to handle it, but let's just stick with that for now. So now we'll be running our model for each target. So for target W, we want to check the correlation. For targets R, we want to check the correlation. For target G, we want to check the correlation. And for target B, we want to check the correlation. After trying to do that too, we wanted to see how well they have performed on the validation data, and from that we can try to make submission our test. This will take us we can see that our model takes 7 minutes 8 seconds to load. So in our first for target W, the validation set is 0.15, which is less than 1% accuracy. The target for target how we have 7.969, which is closer to 8%. For targets G, we have 13.2%, and for targets B, we have 20.48%. So mostly in our target W, R, G, and B, you observe that for target B, we are able to get more accurate prediction due to the Spearman correlation ranking than target G, R, and W. So we want to make submission on the test set, so we don't have to worry about that. Every week you can try to look at how your score is performing in the leaderboard. So we have every Friday to tune our model to make an improvement on our model. So we shouldn't worry about that. So we want to make the submissions by trying to predict on each of the test set targets. So this is our total submission shape, and then finally we have been able to make prediction on our data set. So you can try to say you want to make the submission onto your local machines. I want to show you how to submit your predictions on the CrunchDAO. So let me download this onto my local PC. So on the final note, before I try to show you on how to make submission on CrunchDAO. Try to join CrunchDAO today if you have not done so. Try different machine learning for each target. You can try to use the cat boost model. You can use SG boost. So mostly I can give us a small tips here. If you want to make your SG boost model to be more faster, you can try to use GPUs. So on Google Colab, on Cargo Can, you can use GPU. For now on my side, Light GBM is performing well on the leaderboard. Thank you everyone. I'm going to show you on how to make submissions on CrunchDAO with the prediction I've generated so far. So if you want to make prediction on CrunchDAO, this is my dashboard here. You can see I have my dashboards. You see how the score is doing. The last scoring date is on the 28th of March 2023, and for this submission currently are open, and for it to close we still have 44 hours. So if you want to make prediction for my prediction for this particular, I'm going to go to current rand. If you want to download this week data, you can do that, but I won't advise us to do so. You can just follow through the CrunchDAO API. So let me submit my work again, and I'm going to go to file. So this is the submission I made, and you can try to name it a new submission. So submit your predictions, and if your submission is being successful, it's going to write submission accepted. So why am I doing this? Is just for us to be able to get well started with CrunchDAO-Master-Dataset. And a lot of us have done competition on Kaggle, on Zindy. Mostly we try to have our CSV file and make submissions. There are also different ways in order for you to make submission on CrunchDAO, which I'm going to show in the one of my next video. Thank you everyone for trying to work my channel. Don't forget to CrunchDAO, and don't forget to subscribe to my YouTube channel. Thank you.